Gonna work on a few things. First of all, we're gonna look at Astable Multivibrator. So let's just get into it right now. Um, okay, I'm just gonna make sure that the stream is live. Okay, hi, welcome again to my channel. This is HecaWorld Unlimited. So we're gonna look at Astable Multivibrators, but we're gonna start like as usual. We're gonna start from the known to the unknown, right? So we're gonna start from what we've done before, and then we're gonna just go from there to another place. Right, so let's log in and create our circuits in Multisim. Again, this is a free platform I'm using right now, so you can just create an account and use it to follow what we're doing. Right, you might be watching this later, which is fine. Just follow what we're doing. All right, so what I'm gonna do is to demonstrate an Astable Multivibrator. Okay, I gotta zoom it so you can see what I'm doing. Fair enough. We're gonna lay out our components. First component to lay out, it doesn't really matter, but let's start with a resistor. We need a resistor. We need a transistor. We're gonna use NPN transistor. You can try PNP. Just observe the polarities. Watch the other videos to see how we play around with biasing NPN transistors versus PNP. Then we need an LED. I think with these three, I will just need our ground and the power supply, of course. Okay, so we have this laid out. Let's get into it right away. Okay. All right. Remember, there was a time we discussed transistors as an electronic switch. So let's see how that goes. Transistor as an electronic switch. Okay, I'm gonna put this here. Connect the diode to it. Okay, let me make sure that's space. This diode is an LED light emitting diode. Simply means when you bias it properly, to tell you that it's biased properly, it will glow. So we're gonna do that right now. Sorry, I was just gonna move the ground, connect it properly. This is such an awesome, simple circuit to build. Okay, we're gonna move it around a little bit. Positive goes to this, and this goes to ground. Simple as that. Let's include a switch. Why not? Why not? Can have a switch, and let's run a simulation. You know this is not gonna light up, but just for the sake of doing it. All right. So this doesn't light up. The LED doesn't light up. Why? Because the transistor has not been biased, or at least not biased properly. The base is floating. If this is a phototransistor, you can use light to bias it, but this is not a phototransistor, regular transistor, so we don't expect it to light up. So what we're gonna do is gonna bias the transistor. So to do that, we need to pull the base up, right? So let's just put this somewhere here and pull it up. Okay, to pull up simply means just sending it to the positive rail, right? If it is PNP, you're going to be pulling down, right? So pull up for NPN, pull down for PNP. So let's turn this on and flip our switch on, and the LED is on. Off, on, off, on. Simple circuit. So you have a transistor, an LED, and two resistors, and you have all you need, right? This circuit works fine, perfect. But this is just to prove that the transistor can function as an electronic switch. Ignoring this switch here, when I bias it properly, okay, let's just prove what I'm trying to say here. Make a copy of this switch, flip it around, and connect it between the base and the biasing resistor. Okay, and we're gonna turn it on, close this switch. You see this transistor, the base is not connected, so when I close it, the LED comes on. So the transistor can function as an electronic switch, just turning on and off and letting current to flow. But this is not why we're making this video. Remember, we said we're gonna do a multi-vibrator. But let's just observe what we've done here. Okay, transistor, LED, power supply, and then we bias the base of the transistor and the LED comes on. Good job. So let's make a copy of this circuit and place it side by side. Why not? I said why not? Okay, before we do that, let's move this, because I prefer to do things in a certain order. Okay, yeah, I prefer to place this on this side of the circuit. Okay, any reason for that? Just preference, doesn't really matter. But I'll show you why, because I want to flip one of them around, and it doesn't seem I can flip this the way it is. So why don't we just leave them the way they are, but we want to use the same power supply. Okay, so we're going to delete the power supply from one of them. Okay, we don't want to have two power supplies. So let's use the same power supply for both. Okay, basically we have the same circuit here, just duplicate. Let's run it again. You cannot understand that they will just glow at the same time, right? I mean, there's no difference. The power supply supplies both of them, both connected to ground, base of each pulled up by the same value of resistor. All right. Okay, so we're gonna change these values and see what happens. 1M, this is the 10K, still fine. I'm just gonna choose a different value here, 22K. Let's try 22K. Still glows. Okay, we're gonna make the same value here. So let's make it uniform. You can use any value you have seen. They all glow. So I'm gonna reduce this load resistor, or limiting resistor, if you will. Let's reduce it to make it smaller value. We're gonna also change the value of the voltage supply. You're gonna go into the realm of what we actually want to do today. So let's reduce this value to I don't know, say 6 volts. Should be fine. All right. Now they still glow at the same time, and what we want to do is to show an Astable Multivibrator, which is a circuit that one of them will be on, and when it is on, so let's say Q1 is on, Q2 will be off, and when Q2 is off, when Q1 is off, Q2 will be on. Okay, so to do that, I'm just gonna introduce a new component. We don't have it here, but just one new component in this whole fix, and you have yourself an Astable Multivibrator. Awesome. So this is a transistor switch, but we're going to quickly transform it into a multivibrator. Let's introduce our component, that is our capacitor. We're going to introduce a capacitor right here. Let's just connect it up right away. No, there's no point wasting time. Let's connect it up. We're gonna analyze what happens. Okay, let's connect it up first, and then we analyze how it does what it does. This is amazing. This is amazing. And to know that a capacitor is just what's it called? Two parallel plates. It's amazing. I don't know why I'm using 220. You can use any value. Let's start from 100. We're gonna change it because there's a let's make a copy, and we're gonna connect it up exactly the same. All right, exactly the same. So between the cathode and the collector of the transistor, you have one of the terminals. How do we connect up the floating pins? Right, because if I run this simulator, you see both LEDs are still on. Transistors, both of them are on at the same time, and one terminal of the capacitor is still floating. So to fix this, let's do the trick here. So we're going to connect the one of the capacitors, so in this case C1, we're going to connect it up to the base of Q1, and this small change will do something different. So this thing still looks the same to me. Both are still on, but just give it a second. Okay, so let's run the analysis first. Okay, so what we're trying to achieve is when one transistor is on, so we're going to pick one. I'll explain to you how Astable multivibrators work, and then we can take it from there. So how it works is when one transistor is on, let's say Q1 is on, one of the terminals of C1 is grounded, and the other terminal is charging up through R4. And at the same time, when the voltage gets high enough to bias Q2, Q2 will turn on, and in that process ground one terminal of C2, and C2 starts to charge through R2, and this cycle repeats. And the on time and off time is determined by the ratio of R2 and C1 or R4 and C2. All right, so it's something like 0.639 0.639 or thereabout times RC. Okay, so if the value is very small, you will not notice any difference. Both of them stays on. So right now, it took a little while, but you can see the cycle has kicked in. What I was trying to explain, I think I zoomed it too much. So R2 LED2 is on now. Okay, now it goes back to LED1 is on, and then when it goes off, LED2 will come on, and this cycle continues forever. Again, the value, yeah, I have the time is really high, so times too small, trouble in convergence issues. So we're gonna change the values to just make it more let's make it faster, shall we? Okay, we're gonna run this simulation again. So it really takes some time, so we'll try this. Let's make this 10 microfarads and this one 10 microfarads at the same time and see. All right, so what you can do is make a copy of this. Let's change the limits. So unable to converge. What is the reason for the convergence problem? Okay, we can change the convergence from this simulator. Let's see what is recommending. So we can change some values. Okay, VN toll, apps toll, -6, -12. All right, so we can make apps toll -8, VN toll -4. Okay, let's go back and do that. -8 apps. Okay, so Okay, we're looking for simulation options. So this we're going to reduce, and then I think Astable is -8 and VN -4. Apps. So this is -4 recommended, and this is -8 recommended. All right, so we can then run this simulation one more time. Let's see. So when you're using a tool, try to know a little bit of the documentation of the tool you're using, and if there's a recommended setting, you observe that if you're doing this yourself. Of course, if you built this circuit, you wouldn't have to be doing the settings, because the circuit will just work. It might just take a little bit longer, but it's gonna work. All right. So yeah, this is the circuit. So we've done the modification recommended, and you can see the LEDs are just taking turns to flash on and off. The on time and off time, again, determined by the combination of R and C. Okay, when one transistor is on, in this case Q2 is on right now, Q1 is off, and then once Q2 goes off, Q1 is going to come on. It's going to continue like that. Remember this circuit, we just built it a few minutes ago, where both of them were on basically at the same time, and none of them is controlling the other. But the moment we introduce this capacitor, the concept of time comes into place. T is a function of R and C, right? This is the on time and off time. So we're going to solder up the circuit later. Maybe in another video we're going to show how we solder this, but this is basically it. So you can make a copy. Now you know why I was making a copy, so I didn't want to just draw it over. You can make another copy, place it on any of the sides, connect it up the same way. But the trick is, you take let's say you have the transistors laid up this way, Q1, Q2, and Q3. So you take the capacitor on Q1 to Q2, capacitor on Q2 to Q3, capacitor on Q3 to Q1. So you loop them, so it goes in series and then loops back. When you do that, you ensure that one of them is on at maybe two will be on at the same time and one will be off. And then when that one comes on, the next one will be off. So it's gonna go say off, on, then it's gonna go on, off, on, and it's gonna go on, off, and it loops back. So it will be chasing. You can build a light chaser, right? You can make, if the T is small, it will look like a light chaser, where it just, the off is running around in circles. Okay, so we can try to reduce the values of this R and C and see what it does. We're gonna reduce this, and we're gonna reduce that as well. If you make them the same value, then you make sure that on time and off time are equal, right? You don't want one. If you want one to be on for longer, yeah, of course, you can make the time constant R and C to correspond to how long you want it to stay on. I believe the formula is 0.693 or 639. Check that out. 0.693 multiplied by the value of R and C. That will give you the on time. So it flashes back and forth, right? Okay. Let's reduce this value one more time to 1 microfarad, and this also to 1 microfarad, and see. If it's too small, you won't notice the on time and off time, but if it is too big, it stays on forever. So this, at the value it is right now, you can notice the flashing, right? So we can pull up a calculator and just try to pop in the values and see what it actually is, right? So again, another way to do it is actually 1.44, I believe 1.44 divided by RC. So if you do 1.44 divided by RC, you should be able to get your value. So your on time or off time value, which is basically the same. If they are the same values of resistors and capacitors, then obviously it's going to be the same. So, but if they are not the same values, again, take into consideration tolerances, the resistor tolerances and the capacitor tolerances. So sometimes, even though they are equally rated, the value, the actual absolute value might not be the same. So again, I'm gonna try to put the formula on the corner. Let me see if I can add a note. Can I add a note here? Maybe when I stop the simulator I can add a note. Can I? Okay, so let's add a note here. Actually, I can have the simulator running while I add a note. I think so. Yeah. So the formula, your T constant, is about 0.693 or 94 multiplied by R times C. Okay, so this is the formula you need. So this is your transistor on time. Again, on time will be equal to off time if the two constants are the same. Will be equal to off time if both, let's say transistor, if both capacitors and resistors of each transistor are equal. Okay. I know the reason we say this is because the on time of one transistor controls the off time of the other. If Q1 is on, for that period Q2 is off. Right, and vice versa. Okay, I think the light is going dim, so the video quality is being affected. So I'm gonna end this right now, and we're gonna continue at some other time. I'm gonna try to change the filters because we started this with a little bit of more light, and now I look like a ghost. Okay, yeah. So I'm using the blue screen so you can see it's affecting the quality. But what I wanted to show today is this: how easy you can build an Astable Multivibrator, and I am gonna add the third circuit. Because of how bad the video quality is, I'm gonna hide myself. Okay, but I'm still here with you, right? So we're just gonna hide, and boom, we gone, but we're still here, right? So I don't want you to be watching a ghost. This is yours truly. Okay, so let's make another a copy, right? Let's make another copy, and we're gonna make a copy. So let's copy this and that and that. So you just click one and hold the control key if you're using a window, and I think for Mac you're gonna hold the command key. So we're just gonna click all the connections that we need so we don't have to do them again. Alright, so we're clicking this copy to make a copy, and alright, the connections didn't copy, but it's fine. It's fine, not a big deal. So let's just paste it whatever we want here, and we'll connect it up one more time. So connect it up as usual, same things. Right now this is the wrong. This goes to the base because we want to actually bias the transistor first. Okay, so that's it. So we're gonna run the simulator. Okay, why don't we disconnect all the bases? Because like I said, it's gonna go 1 to 2 and 2 to 3 and 3 to 4. Okay, so this is Q3. We're gonna take Q3 out. Can we take it out? Because I want it to be Q1. You know what I mean? It doesn't matter, just the numbering. Can we change the numbering? Yeah, okay, we can change it. So we're gonna call it Q1. It's gonna have an error because we already have Q1. So we're gonna call this Q3. So Q3 is gonna complain, and then we're gonna go back and we're gonna call this Q2. going to complain. All right, so everything is complaining. Why don't we start by making this a different value that we don't have? Q4 is not going to complain, and then we're going to renumber this, okay, because we never had it before. So this is going to be Q1. Oh yeah, sorry, we're going to change Q1 first. Yeah, make it Q2, and then we can renumber the rest. Q1. No particular reason. If you follow this from the beginning, it's just to have it numbered in a certain way, right? Oh no, this is 3. All right, and then this is going to be C1, C2, and C3. So why don't we just change the C to something else? We call it C4, as we did before. C4, but it's going to be C3. So let's go and change C3 to C1. Okay, I made the same mistake again. So we have to change this first. So we want this to be C2. Okay, C2, and then we want this to be C1. And after that, we want to change this back to C3. Likewise, we're going to do the same thing for the LEDs. So LEDs, this is LED 2, but we actually want it to be LED 3. But we already have LED 3, so we're going to make it 4. Right? And then we're going to change this to LED 2. And finally, we're going to make this, well, not finally, we're going to make this LED 1. And finally, we're going to make this LED 3. One more thing, we want to change the value of the resistors that determine the anyways, let's leave the resistors alone, but I think you got the flow, right? So okay, I know what I'm going to do. Let's make this a little bit easier for us. We're going to change this. Instead of R6, we're going to call it RT1, okay, because it's for the timer. RT1, we should have even called this CT1, but it's fine. So that way we can easily call this resistor RT2. So for timer 2, and then we're gonna call that RT3 for timer 3. RT3 for timer 3. So we can refer to it as we run the simulation. Okay, this is what I wanted to achieve right now. So we'll run the simulation, and we're gonna see all three transistors on. Well, Q3 is not on. You know why? The base was not connected up. So we're gonna connect it up, and we need to disconnect this guy. We disconnected the wrong one. Yeah. Now all three are going to be on equally at the same time. Simple, right? So to get us to run the simulation we did before, where we have a light chaser, basically light chaser, they're running after each other. We're going to loop them up like we said. So to loop it up, again, you take the collector of this, the open terminal of C1 to Q2, open terminal of C2 to Q3, open terminal of C3 to base of Q1. And when you run this simulation, believe you me, you have just built yourself a light chaser. The speed is pretty much, it's too fast. You can notice the blinking. Let's zoom it a little bit, make it clearer. You can notice the blinking is pretty fast. Why? Because the T constant is very low. So let's increase our T's, right? Let's increase our T. Remember, 0.694, 0.693, thereabout, multiplied by CRT or R, if you will, capacitor and resistor. So let's increase this value. Of course, let's increase the value of this. They're going to be equal. if you want to get the same effect. All right, so let's increase. I think we still need to increase it a little bit. We see the blinking, but it's not very obvious. So let's increase this a little bit more. And well, this is a whole lot more, 10 times more. All right, so you're gonna see the light chaser effect right now. All right, so so they're chasing themselves. All right, and the loop continues. It goes on and on and on and on. So we're gonna solder up just two of these. The two is just called the Astable Multivibrator, but this is a tri-state multivibrator, if you will. It's okay. We're just gonna give it a name. So call it HecaWorld Astable Multivibrator. We've built one before, so why don't we give this a different name? So when we save it, it's easier to find. Multivibrator tri-state. Why not? Or tri-state Astable Multivibrator. Let's do tri-state. Really, I don't think this is true tri-state, but what we're trying to demonstrate here is that we have kind of light chaser. Why don't we call it light chaser, right? Let's call it light chaser. All right. So we'll give it a name so we can find it. So if you go to my channel, you can find the simulation, you can find the circuit, you can copy it if you want. It's totally free, so I just want people to learn and know how to do stuff, right? So okay, that's it for me today. I'll be doing another video on soldering, and actually this video is supposed to be about soldering, so let's see if we can make a soldering attempt, right? So we don't have to really solder this Astable Multivibrator today. We can use the soldering video for something else, just show basic soldering principles. That's what I want to get to, basic soldering principles. So I'll show you a few tricks about soldering, and yeah, okay, I'm gonna end this stream right now, and then I'll come back and I'll show you another trick. Maybe it will be a video for tomorrow. This video is live, and soldering video, I think I want to make it live as well, but let's see the lighting system in this place, and I'm in my garage, so it's a little bit dark now. It's about 7:30 p.m. but we'll see how it goes. Okay, thanks for watching, and always come back. We're gonna have more for you. If you have any questions, put it in the comment below, and I will see how I can assist. I have this hunger to teach people. I get joy when I see people learn. So I was a professor also in a college here in Canada. I don't teach anymore in school, but I still have that passion to teach, and I like to give this kind of information to the people free of charge. So you keep coming back to my channel. You can watch other YouTube videos where people just solder things up or demonstrate what they build. But when you come to my channel, you're gonna get a little bit of background, a little bit of understanding how things work, right? And sometimes I do that. Sometimes I just solder something and show you it working, but sometimes I take the time to explain to you the principles. So if you want to watch, go back to the beginning of our basic tutorials to see we introduced transistors, resistors, capacitors, inductors, LEDs, and we looked at transformers, and then from there we're building things up. You can see this Astable Multivibrator started from our transistor switch, which is several videos ago. So we talked about transistor as a switch, but now you see when you have two transistor switches connected in a certain way, just introducing one new component, a capacitor, you are able to build an Astable Multivibrator. But then you introduce a copy of what you just built, and you have this light chaser. Try to make it 4, 5, 6, 7, 8, 9, 10 and loop them and see what happens. I think there might be something interesting. I think when you go beyond 3, you might start noticing something interesting. Some of them will be repeating patterns, but do it and do the experiment. Tinker with it. So after all, science is all about tinkering and observation. So change a few things and observe how it works, and if it can be repeatable, by other people under the same condition, then you call it science, right? So do what I've done and tinker with it a little bit. If you can repeat it and others can repeat it, then it's science, right? So go ahead and tinker with this and document what you've seen, and you can share with others. All right, thank you so much, and I'll see y'all in the next one. Bye bye. Hey, before I really go, um may I ask you to please consider subscribing to my channel, right? So if you haven't subscribed, please subscribe. Keep watching, keep coming back. All right. I think I've said bye several times, but yeah, see you in the next one.